Alright, continuing with simplifying our roots, and then we're going to move into complex numbers. The first we're going to look at adding, subtracting square roots. In order to do this, we must simplify each one of our square roots. Now remember, our square roots: 100, 81, 64, 49, 36, 25, 16, 9, and 4 is the order in which we want to divide each number by to find its perfect square. 20 is the square root of 4 times the square root of 5, which will give us 2 square roots of 5. Plus, square root of 12 has the square root of 4 times the square root of 3, which will give me 2 square roots of 3. Minus the square root of 9 times the square root of 2. The square root of 9 is 3 square roots of 2. Our roots kind of work like x and y's, where each one of our roots can only be combined if the square root is the exact same number. So we don't have any more square roots of 5, any other square roots of 3, or any other square roots of 2. So our final answer is written here. Looking at another problem, we have to rationalize our denominator, meaning we cannot have a square root in the denominator. So in order to do that, we multiply the top and the bottom of a fraction, which would be the same thing as 1 over 1. So we can rationalize it. So we get 5 square roots of 3. The square root of 3 over the square root of 3 times the square root of 3 would be the square root of 9, which gives me 5 square roots of 3. The square root of 9 is 3. So one property we do have of our roots is anytime we take a root multiplied by itself, we will get what's underneath, because the square root of 2 times the square root of 2 is the square root of 4, which becomes 2. Likewise, if we took the square root of 10 times the square root of 10, that would be the square root of 100, which would equal 10. So if we take the square root of 5 times the square root of 5, that's just going to give us 5. Let's look at complex numbers. In our complex numbers, I equals the square root of -1 because it becomes imaginary. I squared would be